I want to welcome all of you to Python for Business. I think it's exciting for us to bring this course to you. I spent the last month trying to do my best to organize the material for this course and make sure that you will have a wonderful learning experience. So let's get started. Today happens to be Mother's Day. I think it's a wonderful day to start. I just want to take a moment to remind all of you that maybe when you finish this call, maybe you'll do something nice for your moms or give them a call. And for those who are moms who are on the course, happy Mother's Day too. Okay, so I guess to be a little philosophical, every journey that we take, which is the journey of 1,000 miles, starts in a simple way. It starts with just taking one step. Right, and you've taken the first step, and I want to congratulate all of you on taking this first step. We at ACAD, we want all of you to be successful in your learning experiences, and we will be with you on every step of this journey. So one important thing, do not hesitate at all to reach out to us in any way that we can help. We'd be happy to respond to each one of you one-on-one. It's the luxury of having a small class is that you have access to us, and we want to be able to help all of you in any way we can. Quickly, let me just talk about our motivations for starting ACADS. We wanted to start ACADS so that we can make learning, successful learning, accessible to all of you. And we want you to have high quality learning experiences. As you know, today, there are so many different ways in which you can access learning. Plenty of MOOCs are available. Many books are available. But as a learner, I've been a lifelong learner myself. I find that some of these learning experiences are not necessarily of the highest possible quality based on the tools and techniques that we have today. So we at ACADS have put a lot of energy into trying to make sure that you have access to high quality learning experiences. And we've taken all of our many years of experience into shaping these learning experiences for you. As you all know, the market forces are reshaping the market so rapidly. And so we want to make sure that these courses will give you a learning path that will eventually lead you to better career opportunities. Another important point which we want to talk about is that we at ACADS are trying to tap into global expertise, right? So wherever we find there are experts who share and are committed to our mission of bringing high quality learning experiences to all of you, we want to include them in the ACADS family and use the ACADS platform to enable them to deliver courses, content, and material to you so that we can have a rich set of course offerings that you can access. Another important note from our perspective, certainly Manish and myself, profit is not our primary motive. We want to make sure that you are successful learners, and that's where our major satisfaction is. And of course, a personal message from me, I do believe that the world needs a lot of skilled people, and you will be part of this skilled workforce soon. And together we can make the world a better place. Just wanted a quick thing about logistics. I mean, I do not want these sessions, maybe the first session is a little bit more of me talking a lot. I want these sessions to be extremely interactive. I just thought I'd take the first 15 minutes to kind of give you some background. And so there's a little bit more of me talking and a little bit more of slides. This will not be the case going forward. We'll almost always plunge into some kind of interactive exercise very quickly. And you'll get a good flavor of that in the second portion of this session too. Couple of important points here is that I want to talk about this idea that we can, in ACADS, we try to focus on a few key pillars, and I want you guys to be aware of them so you can notice these pillars that we built ACADS on as you work. So not so much today, but even later part of today, live interactive sessions. We think that working with you, interacting with you would be the best way to keep you motivated and continue to learn. I already mentioned the access to expert instructors. The other thing is that the pedagogy, the curriculum that we want to use is something that we have tested a lot. And so we want you to have access not to a beta test, but to curriculum that we have tested with learners multiple times. Something that we will bring in later is that as you are learning, we want to give you a flavor of what is going on in the industry. So we can give you access and will bring you access to people who are actually working in the industry. And I think rather than these lessons and these sessions being academic, our goal will be to give you real world experiences. So you will see this right from the get-go, that we will be thinking about and talking about things that will be useful to you when you go out into the real world and try to build programs, platforms, systems, etc. The last thing is that there's this nascent but emergent field of computational thinking, which is to ask the question, how has our 50 plus years of working with computers reshaped the way in which we think about the world? And that leads to an entire branch of computer science as opposed to computer programming. And we will, wherever I get the opportunity, I will highlight aspects of computational thinking to you. Just one more important slide that I want to draw your attention to in this first session. If you ask me what are the ingredients, or what do I think are the ingredients for successful learning, I want to stress that the two main ingredients are a strong motivation, which is something that each one of you has already demonstrated by signing up for this course. I want to encourage that motivation. And then the ability to keep focus and stay committed to the goals that you set up for yourself. So if you're motivated and focused, then the next key ingredient that you need is a good process. And this is the part where we at ACADS can play a big role for you. We spend a lot of time thinking about what is an ideal or a good process for students and people who want to learn a new topic, whether it's programming or it's data science. So we will work with you on giving you access to a good process, which means quality materials, the experience, the chance to do good exercises, get feedback, etc. And then the next ingredient, which is so important, is practice, right? And I don't mean just logging hours, but concentrated and deliberate practice, right? So if we can put in deliberate practice, then I think we can make a lot of progress. And the last essential ingredient, if you're doing practice, then we need good way to get feedback on how well we're doing. And I think here for this course, you will get feedback in 2 or 3 different ways. I think definitely you will get feedback if you ask questions, but also you'll get feedback from some of the quizzes and exercises that you do. You'll get feedback from a couple of the longer project-like things that we'll work on in the latter half of the session. And of course, you can, and we encourage you to participate in discussion groups and get feedback from your peers and share your insights and ideas with them, right? So with all these ingredients, I want you to be mindful of each one of these ingredients and incorporate them mindfully into your learning process, right? Make sure if any one ingredient is lacking, then make sure that we, bolster it and make sure that it's giving you the full benefits that you can have. So I think this is something I cannot overstress, because some people, especially those who are trying to switch careers, rejoin the workforce, etc., wonder, will I ever be a programmer? Can I be successful in learning? And so I always tell people, all of us are born with the potential to learn and be successful. And I believe it. And when I work with each one of you, every one of my conversations, at the back of my mind is a strong belief in your ability to learn and be successful. I also want to say that you are going to be challenged as we go along. There's going to be a moment when you wonder if you can do this. There's going to be a moment when you feel a little bit outside your comfort zone. But I want to stress to you that that is part of the learning process. right? If you do not feel a little uncomfortable, maybe things are too easy and maybe you're not learning enough. What I want you to know is to recognize this feeling of challenge and discomfort and find ways to work through it. And as you work through it, you will eventually be successful and you will start incorporating the learning into your routines. I do want to take this moment to ask you to think about something that you have learned, whether it's learning a bicycle, a new sport, a language, and reflect on the fact that you must have felt a little bit of how can I do this and how uncomfortable does this feel. Okay, so like I said, just to summarize that, and the only reason I summarize and stress this is maybe this is the last time we talk about this. I want you to kind of incorporate this into your lifestyle. I'm sure that you can use this in your learning processes, not just in this course. So, and also in terms of roles and responsibilities, I want you to be responsible for your focus and motivation. We do monitor our energy, our time commitments to things. Here, I'm asking for a focus and motivation commitment from all of you, right? And then I and all of us at ACADS will work on this process with you. And if you put in the practice in the hours, success is yours. So let's get started.
So John, sorry, I'll take a interrupt for a second. Since Niels is here, we'll see if he may want to say like a couple of words, right? Okay, so let me check. I'll unmute Niels. Hey Niels, can you hear me?
Yeah, I hear you. Okay.
Okay. Do you want me to turn your video?
Not put my video, but not my video because.
Okay, okay, go ahead. So just before Niels speaks, I can just give you your background. Niels is the founding director of Financial Mathematics program at University of Chicago. He got his PhD in mathematics from MIT. He was a professor of mathematics at Princeton University, and he's been teaching mathematics at University of Chicago for over 25 years. And he's a well-known mathematician. So I'll pass it on to Niels to say a few words about the courses at ACADS. Niels, all you.
Okay, thank you. Well, I'd like to agree with Vijay's very nice explanation of what we're trying to do at ACADS. I have to say that it's very important that you get involved. The difference between ACADS and many of the other mooches is that we really require that the students get involved in this. We don't have 10,000 students, we have 30, and there's lots of opportunity to get involved and ask questions and ask the instructors and really get involved and participate in the class. And that's the real difference that we feel that we're adding with ACADS. So do take advantage of that. Please get involved. Ask all the questions you have, and really involve yourself in the course. It's a different platform. It's not like sitting in a classroom that maybe we're used to. But with a little bit of practice, I think we can recreate the same feeling as being in a classroom. So that's my message to you. Get involved and learn as much as you can. We'll later on in the year here, we'll be teaching a course on machine learning, and what can I say? The same things will apply to that course. Involvement and sort of direct interaction with the students. That's what's important to us. So I'll let Vijay take over again, and good luck with the courses. And I look forward to seeing you at the later course in machine learning, as I said. So thank you.
Thank you, Niels.
Thank you, Niels. I just want to say, Niels is one of those brilliant mathematicians who does not state how much he knows. Our job, certainly mine and all of yours, will be to pick his brain and extract as much information as we can as we interact with him. Niels, really appreciate you making the time to join us. And hopefully everything we say will be entertaining to you as we go forward.
I hope so.
And look forward, and like I want everyone to understand, we continuously work on improving ourselves. So like when Niels is on this course, or Manish is on this course, when all of you are on the course, we will seek your feedback, and we want these courses to continually get better. So please do reach out to us with anything that we can do to make things better. Okay, so let me just pick up. Hopefully, can you guys see my screen right now? Okay, so I have to share something. Okay, can you see my screen right now?
Yes. We'll use chat as a medium to communicate most of the time. Yes.
Okay, yeah, so maybe we will try this. We will experiment with lots of different things. Maybe we will try this idea that you guys can use chat right now. Manish is monitoring chat. He will curate any questions or comments you guys have, and then he will jump in and share them with us as needed. So please feel free to use chat. You can also exchange some comments with each other as we go along. Okay, so let me get back to what we were talking about. Except that my slides are not on full screen, right? So just give me 1 second. Okay, so this should be better. Are you guys able to see it? Okay, so let me just start off with something that's, as I've been thinking about coding, I want to leave you with something that's really, really important. When we approach programming and coding, we think that this is an activity that we do in order to make a machine behave the way we want. This is our ability, our desire to communicate with the machine. And this is how we need to communicate with the machine. But I think in reality, we could communicate with the machine in many different ways, but our structured programming languages are really a way for us to express our ideas. But express our ideas, we can always do this in speech or in text, but choosing to use programs is a very specific form of structured communication. And really what we're doing is communicating our ideas with ourselves and with other people. And so this is going to be a theme that I want you guys to experience as you write programs, is how can we make our programs more understandable to ourselves? How can we make our programs more understandable to other people who read our programs? And finally, how can we express our ideas in their clearest, most precise form as we write our programs, right? So there are many, many programs that can achieve the same outcomes. But the beautiful programs and the best programs are the ones that distill our ideas very clearly and make the communication most effective. Okay, so, and then I want to just introduce this concept, since it's going to be another theme that we're going to use, is the concept of what is computational thinking, right? So for today, I will just give you a few elements that we're going to, actually incorporate in an interactive session very soon. So the important elements are that computational thinking has taught us to ask this question that we don't ask often, which is, how do I represent something, right? So often we are used to actually using something that has, the representation has already been chosen for us. Say, for example, if you do mathematics, the number system is already chosen for us, right? So we don't get to ask the question, how shall I represent a number? But programming and computational thinking gives us many, many, many opportunities to think about representations of things. Again, some of this may be a little abstract for you, but I want to give you a framework in which to absorb new information, right? So the important point here is, when you look around at the world today and you think about writing programs, one of the most important questions in writing good programs is to ask about the representation of things. I will highlight this as we go along and call your attention to moments when we actually represent things in different ways, and we can talk about what's the best representation for a particular idea or a problem. The second thing, which I think we are more familiar with, we understand this idea that the best way or a good way to solve a problem is to break a problem into smaller parts. But I think computational thinking forces us to acknowledge this, and also forces us to put our attention into asking what are the smaller parts that we should use, right? And you're going to feel, I don't know if it was very structured in your learning experiences in school when we were first introduced to word problems and you had to write statements. I certainly felt, why do I need to do this? I can just find the answer, right? And then later you learn that the reason you need to write statements and break down problems into smaller pieces is that in life we are going to encounter problems that can be large, that can be big. And if we try to solve them all in one chunk, it may be too hard for us to solve them. So it's always wonderful to understand how to decompose a problem into smaller parts so we can solve it. Then the next important idea here is there are a lot of programmatic tools that we can use. For example, if I have a repetitive action, how do I get a computer to perform a repetitive action multiple times? That will lead us to an idea like iteration. And we'll talk about logical operations and many, many programmatic tools that will also shape the way we think about things. So when we ask a question about a particular problem, we might start asking the question, can I solve this by iteration? Can I use a logical operation to make a choice here, etc. And when we put all this together, the next important thing is kind of algorithms and algorithmic thinking. So now this is, of course, a big, interesting word named after Al-Khwarizmi, which is an Arabic mathematician, right, which became the word algorithms. But what does it mean? It's this idea of breaking a problem into a sequence of smaller steps, right? But a very well structured and well thought out sequence of smaller steps. Now that sounds abstract and vague, but one of my hobbies is I like to cook. So if you, and for those of you who like to cook, you can see that there's a recipe, right? And there's a sequence of instructions that you have to follow. And almost all cooks will follow that sequence, especially if you're baking. You don't want to break the sequence, right? You have to incorporate ingredients in a specific sequence. So that's kind of an algorithm. For example, an algorithm to bake a cake, right? So would say powder the sugar and mix the sugar with the butter and so on, right? And so algorithms are everywhere. Programming algorithms can be applied to very specific problems, and we'll start recognizing them. And maybe some of you will even invent some new algorithm. But for most of our study and most of the initial part of anyone's journey into the world of computers, we use algorithms. We don't necessarily create algorithms. So having a nice library of algorithms that we understand and we know how to apply to solve different problems will give you a tremendous leg up in solving problems as you go along. And then the last question here is asking this question of how efficient is my solution? So this is something you can bring always into every aspect of your life, is to ask the efficiency question. But the efficiency question, apart from some applications in running large enterprises and running industrial machines and so on, is extremely frequently asked in programming, right? So as soon as you write a solution, almost always we start asking questions about efficiency. So much for computational thinking. Maybe I can pause for a second and see if anyone has questions.
I'm going to unmute everyone so they have opportunity to ask questions. But probably the better way is to raise hand, but if they do not know, I'm just unmuting everyone. So make sure you do not have like noise in the background. If you have noise in the background, please make sure your microphone is muted. Anyone has a question for Vijay, they can ask.
Please don't feel intimidated to ask questions. There are no bad questions in my world, so please ask, and I'll be happy to address anything. No. Okay. So shall I continue?
Yeah, sure.
Okay. So the next important question for us is, of course, here we're learning programming. So why learn programming, and in specific? The most important why for me is the skill to express your ideas in code. And as we go along, you will see, just like learning a new language, you start thinking in a new language. The moment you start thinking in code, I think you've arrived as a programmer, right? Initially, you're going to think in your way of thinking and translate into code. That's how we learn any new language, is to translate from what's familiar into what's unfamiliar. But as you practice writing programs, you're going to start to think in code. And that would be a wonderful moment. And I'd love to hear from you when you actually feel like you're thinking fluently in code. The next important thing is we want to be able to write programs to solve problems, right? To solve problems, to explore the world around you, to automate repetitive procedures in your life. These are all things that are possible given the power of the computers that we have today. And the next area that some of you have in your goals is this area of wanting to specialize in these new and rapidly growing fields of data science, machine learning, AI, and robotics, right? These fields have seen a tremendous resurgence recently for various reasons. But the most important reasons that I see, at least in my own search through these fields, is that we have started to recognize how powerful our computing environments are, and we've started to recognize the power of data. And rather than building systems based on rules that we code into computers, we can now give computers the power to learn and discover rules for themselves. And as soon as they learn and discover rules for themselves, we get a very powerful result, right? So for example, the simplest example I want to give you here, just to get you excited about the possibilities at hand, is one of the outstanding problems that we had was to figure out how to translate from one language to another. And our original attempts as computer scientists was to write a set of rules for translation. And I still think it's a wonderful way of solving the problem. But to our surprise, we found that when people took large data repositories, for example, if you take the United Nations, almost all the conversations at the United Nations have been translated from one language to another. And if you take all that data and give it to a computer and say, can you please figure out for yourself, computer, the rules of translation? And computers have been able to do that so well that today translation, at least a reasonably good translation, can be done by a computer. Of course, if you take poetry or a very complex piece of prose, the translations may not be so wonderful, right? But just to give you a flavor of our discovery, that letting machines discover the rules based on data has given us breakthroughs in many, many areas. And the last one, which is maybe before this data science revolution that we're expressing, the last one, which is still a very important part of the world of programming, is to create applications, right? Apps that run on mobile platforms, or applications that run on desktop computers, which enable big companies to run, enable people to run finance, say, for example, trading applications in a financial services company, or an insurance application in an insurance company, or just an e-commerce website, right? These are all platforms that give us capabilities. And as a programmer, you can contribute to developing these platforms. Also, if you have an interesting idea, you can translate your idea into a successful platform or application. So these are the main reasons to learn programming. And I would just switch over now. Maybe I want to just take a minute, if it's okay for you guys, just to say, when you come to these sessions, there's an important thing that I'd like you to do, which is challenging but important, is we have carved out this hour and a half. You have carved out this hour and a half dedicated to making you better at thinking, better at communicating, better at writing Python programs, right? So if you can make sure that you're fully present, that you're relaxed, that you're able to participate actively, that would be the best way for you to get the most out of these sessions, right? And just as being present, be productive, right? Take notes, ask questions, write code. We will have opportunities even today to do some of it. Also prepare. I think if you take a few minutes between sessions to prepare for the next session, then I think that would also help. and stay focused and motivated. I cannot stress this enough. Also, I think we did this, and maybe I can ask this as a question. We had sent out an email asking you guys to log in and maybe post a few posts into the discussion forums. I did not see any posts. Did you have any problems with either accessing the website or posting to the discussion forums?
Do you want me to unmute everyone, John?
Yeah, maybe you can chat, Manish.
Yeah, chat will be better.
Maybe that will be the best way to do it. If you had any problems, or if it's just a question of not having time, then I will walk you through that quickly in a moment. But I would love to see a little bit more interactivity on the forums. Remember, one important ingredient for us is that you are a wonderful batch of students. I took some time with Manish to look through the group of learners that we have, and you have a wide and varied background. So if you interact with each other, I'm sure there's so many things that you can learn from each other. So please be active on the forums and develop this wonderful, wonderful network of beautiful people that are now committed to learning Python, right? So apart from learning Python, I'm sure there's some great life lessons you can have by interacting with each other. So I really encourage you to do this. I myself tend to be an introvert sometimes, so I hesitate to go out there. But I think if you get a little outside your comfort zone and participate in these discussion forums, soon enough you will be rewarded a lot. We will do this together, but we'll take a moment to always go back to the course outline and use that as a scaffolding to arrange new ideas as they come your way. And I talked about practice earlier, but now I'm going to ask, and maybe again, you can do this on chat. I wonder how many hours of practice you're going to commit. And maybe you can think about this, and I will quiz you, or I'll ask you to do a poll on this topic. But, 3 to 4 hours a week outside this classroom would be wonderful. If you end up doing 2 to 3 hours a week, that would be wonderful too. Anything more than 0 would actually be something that would make me happy. But we'll see as we go along.
And John, one other comment. They can ask question in Hindi and Spanish as well, right? Spanish, can you handle?
Yeah, Spanish. Italian is better for me. But Hindi, Tamil, Malayalam should also work.
Yeah, so don't hesitate. Even if you feel like you want to ask question in Hindi, that's perfectly fine, but ask questions.
Yes. I will speak Hindi with a vague South Indian, Italian, American accent. But I would love the opportunity to interact in multiple languages. That's a beautiful tradition of languages, which gives us access to so much expression and history. And we can talk about human languages versus computer languages at a later moment. Of course, if you ask me questions, I'll have to talk about it right now. So quickly, I want to just give you a brief idea of our... Manish, you are monitoring the chat, right?
Yeah, yes, I am.
The first session, which is today, we'll talk a little bit about computers, programming, and Python, which is going to be interactive, but hopefully fun. In the second session, we'll talk about functions and how you build your programs from how we talked about breaking a problem into smaller pieces. This will be a wonderful way to break a problem into smaller pieces. I don't want to go through this list in detail, but I'll just skim through it quickly. The third session is when we start talking about a wonderful field of programming, which is almost entirely driven by a beautiful piece of mathematics by Boole, where he actually set off to figure out how to model human thought. And he came up with this beautiful idea of Boolean algebra. And a lot of our logic is built on top of the work of George Boole. So we'll talk about how do we make choices in programs. And we talked about iteration earlier, so we'll also talk about how to do repetitive actions. As you can see, I've arranged everything along conceptual building blocks, right? I want this course for us to be more about ideas and concepts. And of course, you will learn the syntax, but as you understand the ideas, the syntax will become easy, right? So it's more about my effort to share important ideas with all of you. Session 4 will be very interesting because it will talk about structure a lot. It will talk about groups of things and how we manipulate large collections of things. which will be very interesting and expanded upon significantly when you come to building real world applications, especially data science applications. And then session 5 and 6, we will have plenty of opportunities to converse with each other as we go along. So when we get to session 5 and 6, I want to make them almost entirely focused on writing larger programs. Maybe we'll write a couple of computer games, and session 6, we will do a little bit of computer graphics, right? But as we go along, if you have questions or things you want me to discuss, definitely reach out to me and we can supplement this list with some of your wishes as well.